Imagine that the number line shown below is balanced on a fulcrum at the point x equals 0. So talking about like right here, like a little fulcrum, right? That's holding it up, a little balance beam. There's our fulcrum right there. Okay, we're trying to balance this thing. 2 points are shown on the number line together with their weights in pounds. Place a third weight of 1,000 pounds on the number line so it will be balanced. So you got 450 pounds right there. You got 400 pounds right there. Here's the fulcrum. Where are you going to put the 1,000 pound weight? Somewhere over here, right? You're going to put, I don't know, maybe here, 1,000 pound weight. Put it further out. It'll weigh heavier, it'll have a bigger moment. So anyway, where? Where exactly are we going to put the 1,000 pound weight? That's the question. How do we do it? Well, here's the notes on the um, course Canvas homepage. Choosing a point to bring balance on a fulcrum at x equals 0. There we go. Step 1. Calculate the m0, or for points, we have points. M0 is m1x1 plus m2x2, etc. So step 1. So m0 is m1x1 plus m2x2. So that's the moment about the origin. So here's the origin right here. The moment or torque, if you take physics, about the origin, right? Basically, the further out a weight is and the more it weighs, the more it tends to, if this is the center, pull this line down. The further out the weight is and the heavier it is. So the moment about the origin. So M1, mass 1, this is mass 1, this will be mass 2. 450 pounds out at x1 is 4. This is x1, this is, and x2 right here looks like it's 5.5, right? We're only going to go in half jumps, so 400 pounds for M2 at 5.5, 5.5, x is 5.5. Okay, so let's calculate this. If you go to Desmos, I did it. That's not Desmos. Here's Desmos. You see the top line up there? I put it in. It's 4,000. Comes out 4,000. Okay, that's the moment about the origin. Step 2. So step 2 says given the W equals the weight of the balancing point. Well, they give us that, 1,000. Step 3, solve this equation. M0 plus XW equals 0. So step 2, the weight is 1,000. Now step 3, what's the equation? Right here. So it's going to be M0 plus X times W is 0. So M0, that's 4,000, plus X, that's the X we're trying to find, times the weight of 1,000, right? The weight's 1,000, equals 0. Because basically, the reason that works is we want the thing to balance at 0. We want the moment, which these two weights are making a moment of 4,000. We want that to be balanced. When we add that together with 1,000 pounds at some X value, see how this is just the mass 3 times point 0.3, basically, or x3. See, because the equation was just mass 1, x1, mass 2, x2. This is basically the third x value. This is like the third x value, and this is his math. You want mass, and you want them all add up to be 0. You want no moment about 0. You want it not leading to the right or the left, but have no moment. So how do we solve that equation? That's easy for a Calc 2 student. Jump that 4,000 over there. And so we get x times 1,000 is minus 4,000, and divide by the 1,000. Boom. X is -4. So right here at -4, we should place the 1,000 pound weight, and it'll have a -4,000, right? Because it's mass times its x, -4,000, meaning it'll pull this down at a 4,000. Well, it's really foot pounds, assuming these are feet, foot pounds this way, and these weights together, all together, will pull down also with 4,000 the other way, and it'll be balanced. It'll balance right on the fulcrum at 0. So that's where you need to put it. Use the little tool and just pop your dot right there. You know these dots are only going to be at whole numbers or halves, so that's helpful. And so there we go.